Welcome to Incipient Ed Labs, where we try to make mathematical concepts easy through innovation and research. This is the first of the series of video that we'll be doing on the mathematics tutorial. And today we will be looking at quadratic equation, and under it we'll be talking about discriminant. Many of us are quite familiar with the concept of quadratic equation. And for those that are not familiar with the general format of a quadratic equation, it is given as y equals to ax squared plus bx plus c. A, b, and c are constants, and it is very compulsory or very important, let's put it like that, it's very important that we understand the concept of a, b, and c. A is whatever is beside your variable that is having power 2 or power square. B is what is beside the same variable with power 1, and C is the number. It's a constant that has no variable beside it. So we have y equals to ax squared plus bx plus c. It is quadratic. For those of you that do not know, it is quadratic because the degree is 2. In other words, the highest power of the equation or the expression is 2. So now, discriminant. Discriminant is given by the formula b squared minus 4ac. It is the prediction of the nature or types of the roots of a quadratic equation. We are familiar, for those familiar with the topic as well, we know that for every quadratic equation we have two answers, right? Those answers are what we call the roots. Now, for us to know the type of roots that we are going to have even before we finish solving the quadratic equation, we use the concept of discriminant to do that. Now, how do we know the types of roots we are working with? So we have cases or scenarios. The first test is when the discriminant is a perfect square. The roots will be integers or fractionals. Our second test is when the discriminant is greater than 0. The quadratic equation will have two roots, and when the discriminant is less than 0, we expect the equation to have no root because we cannot find the square root of a negative number. That will lead to complex numbers. So when the discriminant is less than 0, the equation has no root, and when the discriminant is 0, that means the equation has just one root. Let's look at some examples, and the first example is what can be deduced from the values of the discriminants of the following quadratic equations. So our first question is 2x squared minus 3x minus 5 equals to 0. So from the formula of discriminants, b squared minus 4a minus 4ac. So we know we have to look for our a, our b, and our c. As a reminder, a is what is beside the variable with square power, b is what is beside the same variable with power 1, and c is a constant without a variable besides it. So in this case now, so we have our a to be 2, our b to be minus 3, and our c to be 5. So the next step is substitute these values into the formula of the discriminant. So we have our d here, this line. So you see minus 3 all square, because b is minus 3. That means the whole value that b is holding, which in this case is minus 3, must be squared. So we have minus 3 all squared minus 4 times 2 times c minus 5 as well, because c is minus 5. Now the minus 3 all squared will give us 9, and negative times negative will give us positive. I'm talking about the negative in front of 4 and the negative of in front of 5. When we multiply the two, we're going to have positive Then 4 times 2 times 5 gives us 40. 9 plus 40 is 49. Now observe, 49 is a perfect square. So as a result of that, it's pointing to the fact that the roots will be 2. That means we are going to have 2 roots, and the roots are going to be rational numbers. Rational numbers are numbers that can be expressed in terms of fraction. Please pause the video and look at these examples as well before we proceed. Alright, welcome back. Second example, 2x squared minus 4x plus 2 equals to 0. The process still remains the same. Bring out your variables, the constants rather, your a, what is beside the x square, which is 2, your b is what is beside the x, which is minus 4, and your c is 2. So after that, we substitute our a, our b, and c into the equation. The same process. Now observe that our discriminant is 0. So based on what we have said from the standard or the cases or the scenarios, we said when the determinant is equals to 0, it means that the equation has only one root. Alright, so repeated roots. Alright, so now let's look at finally the last question that gives us the third case, which is the fact that our discriminant can be negative value. So you see, from the third example, our discriminant is minus 24. So we said that if the discriminant is less than 0, it means that the equation has no root. You can pause the video, check the examples again before you proceed. Welcome back. These are questions or exercises that we can solve to practice or reinforce what we have learned from the previous slide. Please do good to solve them and hint us on what you get. Thank you for watching the video. See you again in the next video. Thank you.